So for this question, they're telling us, well, what they're telling us is, hey, we've got this normal curve, and we know we've got this z-score, whatever it is, and we know that it accounts for 75% of the distribution. Well, since it's more than 50% or more than 0.5, I know that it's a positive z-score. Then they're asking me, okay, so what if we take that same z-score, whatever it is, and have the negative value of it? That's what it's saying, from negative z to positive z. Well, because these distributions are symmetric, if the original z-score had 75% to the left, that meant this tail area is 25% to the right. And since these are symmetric, there's another 25% down here. And if you think about that, what is all of this that's left here in the middle? Well, that's going to be 50%, or 0.5. And that's what they're doing with that. Okay, just to go on this with another route, suppose they'd ask me this, that I've got some z-score, and I know the probability of that's less than the distribution that's less than that z-score, whatever it is 0.6 or 0.60. That tells me the separate tail area is 0.40. They're telling me, oh, I guess I should say that what is the probability of z is less than, how did they word it? Z star is less than positive z. I'm not quite sure how they worded it without looking at it. But basically what they're asking, if this is 40% above, the negative of it will be 40% below. What percent's in between? What percent's left over? Only 20%, or 0.2. Okay, so maybe that'll help you. Now this question's asking us, what z-scores cut off the middle 95%? Well, back when we were doing the empirical rule, or the 68, 95, 99.7 rule, would say 2 to negative 2. Now they're asking us to be a little more exact. So if you look at, before I leave this, if there's 95% in the middle, there's 5% outside of it in these two tail areas. So 2.5 and 2.5 is there, right? So what we're going to do is go inside the table, and we're going to look for as close as we can get to 0.025, right? Because that's what that is the decimal. So 0.025. Let's see. 0.028. Looks like I'm going the wrong way. 0.0250, right about there, exactly. And if we look, that's negative 1.96, and that's where they got that. And of course, if it's 2.5% below, it'll be symmetric up above, so that's why they're saying it's the positive. So this is the same deal. We've got 98% in the middle. That leaves 2% in each tail. So 2% in both tails. Half of that in each. So I'm going to go inside my table and look as close as I can get to 0.0100. Let's see. Looks like I got to slide that table up. So let's see, 0.04, 0.02, 0.099. So I guess this is a little bit, this is close. That's in between. It's actually in between those. But because this will definitely catch, if I go, let's see, where am I? Negative 2.33, that will make sure I'll have just a little bit more than 98%. If we go to that applet, it would get a little bit different answer. It would be somewhere in between, or the negative 2.33. We're limited to the accuracy of this table. Okay, so hope that helps there. This last one is, let's see, we determine the weights to delineate the middle 90%. Well, if there's 90% in the middle, there's 10% outside that range, which is 5% below it, 5% above it. So if we look at that table, so I'm going to go inside this table and look as close as I can for 0.05. So it's right in between here. So There's a z-score of negative 1.6. Let's see, negative 1.6. I guess we'll go with the lower value, so 1.65. So then to do this by hand, we're going to have to do a little algebra. So if I know the z-score is found by taking the measure minus the mean divided by the standard deviation, and I already looked up the z-score as being negative 1.65. If we don't know the measure, that's our x. We know the mean is 9, and the standard deviation is, what are they telling us, 1.1? So the algebra we're going to do is we're going to multiply this times 1.9, 1.1 I mean, and then we're going to add 9. So if we do that, if we multiply that, that's where we're getting the 0.719, and then to get the positive of it, well, there's a couple of ways to do it. One way, that's probably the easiest way, is just treat that as a positive 1.65, because remember, this z-score of negative 1.65 is symmetric to the positive 1.65, and that's where you're going to get the other value. Okay, if you multiply the positive 1.65 times 1.1, and then add 9 to do it. And you can also do this with that applet very handily. Applet, I said there's a 5.0 area to the left is 0.05. Told it the mean, the standard deviation, and had it calculate below. So a z-score of 7.19 is the cutoff of the bottom 2.5%. Notice that agrees with that answer. And then for the upper tail, I said I just switched it so it was above, so it's taking the 5% above it, and notice that agrees with that answer, which personally I find a lot easier to do than the algebra. So, you know, keep the applets in mind.